In this mini lecture, I'm going to continue looking at how the first derivative of a function f prime of x describes the graph of the underlying function f of x. And in this mini lecture, I'm going to look at something called the first derivative test. So to start with, we've defined what's called the critical number of a function. A critical number of a function is a number c where f prime of c is equal to 0 or f prime of c is undefined. So we've found critical numbers before. Once we find critical numbers, that's going to be sort of important for this first derivative test. So if you look at graph A here or graph B, we see that both of those would have critical numbers at c equals 4. Remember, that's where the derivative is equal to 0 or undefined. The derivative would be the slope of the tangent line. And if we went across the curve here at c equals 4 in A, or c equals 4 in B, those would have horizontal tangent lines. So the derivative is equal to 0 at c equals 4, both in graph A and in graph B. Now in graph A, if we're less than 4, so that's over here, if x is less than 4, then the function is increasing as I'm going from left to right. But if I'm greater than 4 and I move along the function, the graph is decreasing. And that, of course, means I have a local maximum here at c equals 4. The function is increasing to the local max and then decreasing for the rest of the time. We can also say here then that my slope of the tangent line, it's positive here on the left and negative here on the left. That means the first derivative is positive on the left-hand side of c equals 4, and it's negative on the right-hand side of c equals 4. So the first derivative changes sign at c equals 4 from positive to negative. In graph B, I have a similar situation. We've got our critical number here at c equals 4, but here if I'm less than 4, my function is decreasing, which has a negative tangent, and that means the first derivative is negative. But when I move to greater than 4, the function is increasing. My tangent line has a positive slope, and so my derivative changes to positive. So in graph A, f prime of x changes from positive to negative at c. In graph B, it changes from negative to positive at c. So if I have a critical number, in these cases, I have a local maximum and a local minimum. In graphs C and D, c equals 4 would also be a critical number because the tangent line there would be horizontal. But in this case, notice if I look at the left and the right, it's increasing on the left and then it keeps increasing on the right. My slopes are positive on both sides. Whereas in part D, again, I've got my critical number here. It would have a horizontal tangent line, but it's decreasing and then it keeps decreasing. So f prime of x does not change signs. Here, f prime of x is always positive, except at c equals 4 when it's 0. And here, f prime of x is always negative, again, except at c equals 4 where it's equal to 0. And so this leads to this first derivative test that we've got here at the bottom of the screen. If f prime of x changes from positive to negative at a critical number c, then it has a local maximum. If f prime of x changes from negative to positive, then it has a local minimum. If it does not change sign, then there's not a local extreme value or a local extrema at that critical number.